many small bubbles would appear, and then disappear again. These would correspond to mini universes that would expand, but would collapse again while still of microscopic size. They are possible alternative universes, but they are not of much interest, since they do not last long enough to develop galaxies and stars, let alone intelligent life. A few of the little bubbles, however, would grow to a certain size at which they are safe from recollapse. They will continue to expand at an ever-increasing rate, and will form the bubbles we see. They will correspond to universes that would start off expanding at an ever-increasing rate. This is called inflation, like the way prices go up every year. The world record for inflation was in Germany after the First World War. Prices rose by a factor of 10 million in a period of 18 months. But that was nothing compared to inflation in the early universe. The universe expanded by a factor of million trillion in a tiny fraction of a second. Unlike inflation in prices, inflation in the early universe was a very good thing. It produced a very large and uniform universe, just as we observe. However, it would not be completely uniform. In the sum over histories that are very slightly irregular, will have almost as high probabilities as a completely uniform and regular history. The theory therefore predicts that the early universe is likely to be slightly non-uniform. These irregularities would produce small variations in the intensity of the microwave background from different directions. The microwave background has been observed by the MAP satellite, and was found to have exactly the kind of variations predicted. So we know we are on the right lines. The irregularities in the early universe will mean that some regions will have slightly higher density than others. The gravitational attraction of the extra density will slow the expansion of the region, and can eventually cause a region to collapse to form galaxies and stars. So look well at the map of the microwave sky. It is a blueprint for all the structure in the universe. We are the product of quantum fluctuations in the very early universe. God really does play dice. We have made tremendous progress in cosmology in the last 100 years. The general theory of relativity, and the discovery of the expansion of the universe, shattered the old picture of an ever-existing, an everlasting universe. Instead, general relativity predicted that the universe, and time itself, would begin in the Big Bang. It also predicted that time would come to an end in black holes. The discovery of the cosmic microwave background, and observations of black holes, support these conclusions. This is a profound change in our picture of the universe, and of reality itself. although the general theory of relativity predicted that the universe must have come from a period of high curvature in the past, it could not predict how the universe would emerge from the Big Bang. Thus general relativity on its own cannot answer the central question in cosmology: why is the universe the way it is? However, if general relativity is combined with quantum theory, it may be possible to predict how the universe would start. It would initially expand at an ever-increasing rate. During this so-called inflationary period, the marriage of the two theories predicted that small fluctuations would develop and lead to the formation of galaxies, stars, and all the other structure in the universe. This is confirmed by observations of small non-uniformities in the cosmic microwave background with exactly the predicted properties. So it seems we are on our way to understanding the origin of the universe, though much more work will be needed. A new window on the very early universe will be opened when we can detect gravitational waves by accurately measuring the distances between spacecraft. Gravitational waves propagate freely to us from earliest times, unimpeded by any intervening material. By contrast, light is scattered many times by free electrons. The scattering goes on until the electrons freeze out, when the universe is 300,000 years old. Despite having had some great successes, not everything is solved. We do not yet have a good theoretical understanding of the observations that the expansion of the universe is accelerating again after a long period of slowing down. Without such an understanding, we cannot be sure of the future of the universe. Will it continue to expand forever? Is inflation a law of nature? Or will the universe eventually collapse again? New observational results and theoretical advances are coming in rapidly. Cosmology is a very exciting and active subject. We are getting close to answering the age-old questions. Why are we here? Where did we come from? Thank you for listening to me.
Professor Hawking has agreed to answer some questions, and so we gathered a few of the most popular questions, and there were 5. And my job is to read all 5 questions, and he will answer all 5 questions with one extended answer. Some of these questions bear on things he's already said, but you have to realize the questions were made in advance of his talk. Question 1. Do we know for certain how the universe began? Question 2. The problem for most people in trying to grasp all this is if the Big Bang began at all, what was before the Big Bang? I'm afraid I'm going to end up in hell. Question 3 is, how will the universe end and when? Question 4, you say your goal is simple, a complete understanding of the universe. And the question goes on to say, why is it as it is, and why does it exist at all? How close are we, and can science ever answer, and this is in big letters, why it exists in the first place? And question 5 is a very good one. What are the pressing big questions that are left? Professor Hawking.
We are fairly sure the universe began with a period of accelerating expansion. This is called inflation because the size of the universe grows in the way prices go up in some countries. The inflation in the early universe is much more rapid than our financial inflation. The universe expanded by a factor of 1,000,000 trillion trillion in a tiny fraction of a second. Inflation in the size of the universe is a good thing, unlike inflation in prices. It would produce a very large and very smooth universe, with just the right amount of irregularity to account for the formation of galaxies, stars, and ultimately, human beings. How did this inflation start? How can one describe the universe at the beginning of time? I now think I can show how the universe was spontaneously created out of nothing, according to the laws of science. The universe exists because general relativity and quantum theory allow and require it to exist. If I'm right, the universe is self-contained and governed by science alone. In time, we can hope to understand it completely. We have long enough, as the universe should last forever. Eternity is a very long time, especially towards the end, as Woody Allen said. Thank you.
Wonderful.